The slider mate allows two parts to slide along a single axis. In this example, the linear motion bracket will slide along the 10-pitch truss. Select the slider mate. Choose a vertex on the linear motion bracket. A vertex is a line where two faces come together. Now select the corresponding vertex on the truss. You may need to pan around and zoom to be able to see that vertex. Now that you have both vertexes selected, click the Solve button to see the resulting mate. If you're happy with that mate, click on the Commit Current Mate. Now test your mate by sliding the linear motion brackets back and forth along the truss. You may notice that the brackets can go forever along that truss, even to a point where they fall off the truss. Mates that allow motion, like the slider, revolute, and cylindrical mates, can have limits applied to them. Limits allow engineers to apply real-world constraints to the assembly. Double-click on the slider mate that was just created to edit. From here, you can click on the Limits button and now apply the minimum and maximum distances. In this example, we're going to set our minimum to -225 millimeters and our maximum to 0 millimeters. Since our truss is 10 pitches long, with each pitch being 25 millimeters each, the linear motion brackets will stay on the truss with these settings. Click the check mark to apply. Once you've applied your slider mate constraints, slide the linear motion brackets across the truss to see the end result. If the motion brackets still slide beyond the limits of the truss, or maybe don't go all the way to the end of the truss, simply double-click on the slider mate to edit your minimum and maximum distances. Check out Revolute Mate Part 1 to get things turning.